Objective 2, a vertical shift of a quadratic function. So, from objective 1, the parent function we graphed was y equals x squared. Now we're going to graph different functions that we are given, and then compare the new parabola that we graphed to the basic graph of the parent function y equals x squared. So the first investigation we have is y equals x squared plus 2. Now, I need you to get in the skill set or mindset of identifying vertex form initially. Y equals x minus h squared plus k. Vertex form is very key, and that's why they give it to you like this, and that's why it exists. If we look at the power, vertex form with the power, the quadratic power of 2, we notice that h is to the left of the power, and k is to the right of the power. They coincide with an x, y coordinate point. If you notice, x is the left term, y is the right term. So h affects the x value, k affects the y value, because h and x are to the left, k and y are to the right. Please make note of that. So I want you to be able to develop the skill that if given a function here, x squared plus 2, you can identify the location of the power and then look to the left. To the left, there's just x variable. There's no number. So I know that if there's no h value we talked about earlier, there's no h value in this function, that it's going to be 0. So this vertex, the x value, is going to be 0 because the h value doesn't exist. So in my plotted points here, I know that the 0 is going to be the vertex. Now, to the right, if you notice, the number 2 exists. Now the right, we're going to talk about lying to you and telling the truth. The k term is always telling the truth. So I always know that to the right of the power, whatever exists to the right of the power over here in vertex form, is my y value of the vertex. So my y value in this case is 2. So I know that 0, 2 is going to be my vertex, and I can plot that point right there. Now from here, I can use the step pattern, over 1, up 1, over 1, up 3, over 1, up 5, from this vertex. So if I go over 1, up 1, over 1, up 3, 1, 2, 3, over 1, up 5, 1, 2, 3, 4, 5, do the same thing to the left, over 1, up 1, over 1, up 3, over 1, up 5, and I have made my new parabola. That's perfectly fine. If you feel comfortable identifying the vertex, you can use a step pattern every time and it will come out right. To check your work, let's just do the math really quick. If I input 0 into my function y equals x squared plus 2, I get 0 squared with a 0, plus 2 is 2. If I do negative 1, y equals negative 1 squared plus 2. Again, all I'm doing, if I'm actually doing the math, is inputting my table or my values into the x of my function. Negative 1 squared is negative 1 squared is positive 1 plus 2 is 3. So let's check. Over to negative 1, up to 1, 2, 3. So far, so good. Negative 2 squared is 4, plus 2 is 6. So over to 2, up to 1, 2, 3, 4, 5, 6. So it lines up. So far, we're doing great. And then finally, negative 3 squared is 9, plus 2 is 11. And let's see, negative 3, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So they match up. So again, if you can find the vertex, initially you can use the step pattern. Every time, over 1, up 1, over 1, up 3, over 1, up 5, based off the vertex. Let's go ahead and fill in the matching values. 1 is 3, 2 squared is 4, plus 2 is 6. And if I input 3 into my function, 3 squared is 9, plus 2 is 11. So that's how I would do that. There's a couple different ways. Again, you can use the table of values, it doesn't matter. Or you can find the vertex based off of the function in vertex form, and then use the step pattern. Fill in the following. What is the vertex? We already identified it as 0, 2. and it opens up. Now, the other big thing of a vertical shift is the initial thing is you need to be able to compare this to the parent function y equals x squared. Now this is y equals x squared right here. And its vertex is at 0, 0. So you need to be able to describe the shift that is happening. So if I plot the vertex of the parent function 0, 0, and then use the step pattern, over 1 up 1, over 1 up 3, over 1 up 5, 1, 2, 3, 4, 5, over 1 up 1, over 1 up 3, over 1 up 5, and I draw this. Let me draw it in yellow. You need to be able to tell me what's happening at every dot. Let's look at the vertex. Vertex is here of the parent function. This is y equals x squared versus in red, this is y equals x squared plus 2. So if we go back and look at it, vertex here, it shifted up 2 spaces plus 2 here. So again, if it's to the right of the power, it's the k term, and the k term shifts it vertically, either up or down, depending on if it's plus 2, it goes up 2. If it's minus 2, it goes down 2. And every term does that. Let's look at this dot right here. It shifts up 2. Let's look at this dot right here based off of the parent function. It shifts up 2 to get to our new function. And then finally here, it also shifts up 2. Every dot shifts up 2. And if you notice, the x values of this function, the table that we used, are the same as the parent function x values right here. But look at the parent function x squared's y values. We have a 9, a 4, a 1, a 0, a 1, a 4, and a 9. What happened to the y values in our new function, x squared plus 2? Be able to answer me that. What happened to them? And now, from here, go ahead and try parabola investigation number 2. Tell me the vertex first. Try to find the vertex based off of y equals x minus h squared plus k. If you can find the vertex and then insert it into your table somewhere, plot the vertex and use the step pattern, and then check your math after that by inputting all these x values into the function. When you are done with that, please raise your hand and I will come check you.